Wait a second, guys. Logitech string cam. Yep. Hello. Yes, we can take a servo. This is for actually the hardware we use. It really doesn't matter. At the end, everything is a digital signal or analog. In case of this is a PWM, but it's part way on the code, part way on the. So who is here? Both. Amri? Who's that?
Busaina.
Okay. Okay. Sorry. Hello, guys. Welcome. Okay. The camera is here. So let me talk here. Right now, we are on the line end of the course. So we're gonna have two more big clubs today, and the next one that is gonna be for the wildcard week. So wildcard week. So this week we will have what is called the assignment that is wildcard week. That is make something different and interesting. That will depend mostly on each lab and the facilities and knowledge that each lab has. So for next wildcard week, on the club, we will focus on robotic arms again. So today make club will be working a little bit on last week assignment, that is interfaces. For that, we have gained a lot of knowledge already with input devices, output devices, another time how to make interfaces or have interconnectivity through networking also. So that's why we have like the last session of the Firefly that is going to focus on inputs, outputs mixed together, and how to make kind of pseudo interfaces with Grasshopper, for example. And we will spend a little bit of the class also with trying to remind you the low knowledge and how to make the simple scripts for controlling robotic arms. So if you actually want to use the robotic arms on next club, that in case of the academy, you can use for making your assignment on how to use the robotic arm, you need to know, yes, the only way to control a robotic arm is through Grasshopper. So if you want to use robot arm, you need to go on the Grasshopper side. Sorry, 1 second. It's important. Sorry, like the Bluetooth get mixed between the computers. So yes or yes, we need to know how to make the simple scripts for Grasshopper and able to make the file for the robotic arm. You saw that actually within the robotic arm, it's really similar to a 3D printer. We make a file, we put in the USB. The only thing we need to do a previous setup that is actually the calibration of the tool. That is really important. And to acquire this data and put it in the Grasshopper. What is the most difficult part? That the robot does exactly what you want to do without getting into a singularity. That is the point that it cannot turn in that direction, and you need to change the object rotation, etc. a little bit. So let's go step by step, and let's see what we're going to do today. So again, in order, let's share the screen. Share the screen. Share. Okay, right now you see that I'm using a secondary camera. Why? Because I will use the main computer camera to actually work as a webcam inside the Grasshopper. For example, here we don't see right now because this is not with script, but I can see myself in really low quality. Why? Because Zoom takes a lot of resources, and the more pixels you have to compute, lower the computer gets. And you see there are different colors also on the screen. And I have made a rectangle. Let's say this is the influence area. So right now, these points are the average colors of the whole image. But for example, if I have a blue thing, the blue gets into the tracking area and actually is following the object because it's making the average of color. That is like more or less what color tracking does on cameras. So what this value is associated right now, I have this value associated, I don't know if you see on the webcam, but here on the other camera, but here on the table, I have right now an Arduino and a servo connected to the Arduino. And the Arduino is connected to Firefly, that I will open the port. And right now what we are doing, we are tracking the blue color to see if it's on the camera. When the blue color is inside the red square, the servo gets to a different angle. No, we will do the files together. Actually, there are super, like it's 5 lines of Arduino code. So what is happening here? What are the different things that are happening? We have two systems. One is the Grasshopper code, that in Grasshopper what we are doing is opening an image, live image, could be a fixed image. Actually, there's no difference, or it could be a video. And we are simplifying the camera to get less pixels. So we are just reducing the resolution. It's a setting that you open when they open the camera. And what we are doing is like getting the composing of the RGB channel of all the pixels and getting the average between all of them. Like there are some modules that they do automatically that. What we have done then, we have made a rectangle that is actually this rectangle that I have drawn in the Rhino workspace. And I'm checking if this little dot, the blue one, is inside or outside the rectangle. And we can see it here. I will put bifocals so you see the names, bifocals. If the point is in the breadth, inside the geometry, tell me, true or false? With a true or false, what we can do? Or what is the hardware side of the actuation? What do we have in this other side? We have a Arduino Uno. Here. Could be this is an Arduino Uno, but could be any kind of microcontroller that has serial connection. Because this is what we are talking is basically through the USB. Could be a 80 tiny with an FTDI, could be your ESP32 with a FTDI connector or ESP commercial board. But basically what we are doing is talking through serial to the Arduino. It's serial communication. And what we have wire is a Arduino. So what do you think the Arduino is doing inside? What is the code? It's a loop, exactly. And here in the Arduino, here we can see Arduino writing, what is the output? We are writing an A or a B, depends if it's inside or outside. So basically, on the serial, we are just sending A, B, 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 A, all the time. If you look at the Arduino code, is this one? I think I didn't close it. Okay, so this is actually the Arduino code. I just took one of the servo movement examples and modify a little bit. So the first thing we are doing in the Arduino, the code that the Arduino is running is we include a servo library. Why? We want to move a servo. If you don't have a servo, you don't need it. We are initializing the variable servo, my servo. My servo is called my servo because maybe I will have another servo later and will be my servo 2 or 3 servos, my servo 1, my servo 2, my servo 3. And it's going to start in the position 0. What we have in the void setup? First, we want to open the serial communication because we want the Arduino to communicate through our computer with a serial. And we're going to attach the servo in pin number 9. What we are doing in the loop?
For the connection, it's like the 9, the ground, and
For the servo,
yeah.
the servo needs power. We have power that is red, ground that is the brown in most of the servos, and that data that is the yellow one.
So the 9.
In this case, it will be 9. That's why we have 3 cables connected to the Arduino. And we have the void loop. What we are doing in the void loop? Checking if someone is actually writing in the serial. So if the serial is different from 0, we go inside another loop. That is, read the serial, and we're going to call it dato. That is, we're going to read a character, a char. Yes? If the data that we are getting is A, write this position. If the data that we are reading is a B, state this position. Yes? So actually, we are associating different things in the serial. This message could be as complicated as you want. What happens is if you want to activate different things. For example, right now in the serial, we are just sending A's or B. We can make A1, for example, comma, A2, A comma, A3. That's, for example, we will send this message at once. What we need to do later is decompose this message. We will need to split the characters in the commas. So actually, we can actually decompose into several data. You can make a one-line statement, being, for example, you can make your own, let's say, it's making your own protocol. For example, you can write this, being each number for a different output. Output number 1 is in 0. Output number 2 is in 1. Output number 1 is in 0. Output number 3 is in 0. It's low, low, low. So actually, right now, with this message, I'm able to activate different outputs in just one state, low or high, but I'm able, because we can split each character. And you can make these messages as complicated as you want. For example, you can also, let's say, in different values from a sensor. I don't know, instead of sending 1 or zeros or 1 in Grasshopper, we read from 0 to 255 to equivalent analog output, for example. What we can have is like something like this. In this case, we can split every 3 numbers, and we get 3 analogs. Actually, it's about how you split your message on the serial. You can make this really complicated or really simple, as we are doing now. So let's do everything from the. Okay. And let's remember that, for example, right now I have this file open, and right now I'm using both my camera and the Arduino connected to it. It's still moving. So every time you make a new sketch, remember to close Firefly, the Arduino. Remember when we need to open or close the port, remember to do the same with opening and close port. And we will also stop the webcam, just in case, okay? So let's make a new file. New file.
Yeah.
And let's go to Firefly. Firefly. Okay. What is the first thing we want to do? Let's open, for example, the webcam video stream.
What?
It's okay. Carla, can you mute, please? Okay, done. So let's open the webcam, and you can see that right now it's showing this red label. What is the red label? And it's actually showing me the calculation time that the computer needs to show the image. So it's around 21 milliseconds. If you don't get this warning, you can visualize it in display, canvas widget, profiler. It's a quite important component because what we do with this one is actually show if a component is slowing down everything. That is quite common when you have too much data to calculate. So actually, it's just to be display canvas widget profiler. You can hide it or show it. It's not going to do any difference in your sketch. This is about main configuration of Grasshopper. Okay, right now the image is running at 20 frames per second. Do we need this right now? We don't. So actually we can reduce right-clicking on the image and reduce the video resolution, for example, to 40 by 30 pixels. Super high quality. You see that right now the frame per second have increased a lot. Why? Because we can process it in live more than actually we need for getting constant movement. Okay. And you can see that you can also choose different video frame update or capturing devices. In this case, we don't need to do anything else. What we can do now? We go to Vision, and you can see that actually in Vision, we have millions of things that we are able to do. Hide video panel, hide automating controls. Okay. We have a lot of things. Additive time lapse, BMAT sampler, contour vector, gradient, image, mesh from image. One of the fanciest one is mesh from image, for example, that what we need to connect is bitmap to modify. Interval of the fill lines is the range, the Z scale, and show color, yes or no. Right now, let's just connect bitmap to modify.
Mind how to take the full description of the draw?
Okay, how all the lines, no?
Yeah.
Display, draw full names. Draw full names, draw fancy wires, and draw icons. So you get like the full fancy Grasshopper. Okay, so right now, what we have is a three-dimensional representation of our image based on how clear the color is. Black, negative or 0, white, higher Z. You might not see the image like this, smooth. Why? Because right now, I have preview mesh off. You might see something like this. Draw lines. This is a mesh, basically. And we are interpolating every pixel. I don't know if I can draw here. We have, let's say, a grid of pixels. We are making the average of the color. If it's closer to white or black, white being the top, black being the bottom of the Z. It's a scale. So actually, we make the average on the color, and we get a three-dimensional matrix. That's what we are getting. So if you want to see the mesh lines, display preview mesh edges. You can see, for example, if I get out of the image, for example, I have a uniform color, you see it's flat. But the moment we get three-dimensional, it's the simplest way to create an interface. Okay. We have interval for fill lines. That is basically from 0 to 18 is the size of the grid. What is an interval? It's a domain. So if you want to change it, construct domain. We want it to be from 0 to 100, for example. And we are actually changing the proportions of the image. And we can do the same for X and Y. So we can have a square image, for example, or a more rectangular image. Basically, we just changed the scale, but we didn't increase the resolution. The resolution is always based on the image that you are getting. What else we have? The Z scale. For example, we can, it's like multiplying the height of the scene from 0 to 10. So we can make it really flat or really exaggerated. It's augmenting the domain on the Z. And then we can see the color or not, show color or not. What is a true or false? It's a Boolean. So we can see black and white or in color. Yes? Okay. What else we can do? We can augment the threshold, decompose the bitmap. So actually we get, for example, red channel. Let's see what we get in red channel. What we're getting, actually, all the pixels red channel. This one is each one of the pixels color in the red channel. So the first pixel that probably is this guy is 0.45 red. But if I have in green, you see blue has no contains no color. For example, let's see, first pixel, yeah, 0, 0, 0, 0. So the first pixel has 0 red color. And this is actually all the list of pixels. If we have a 40 by 40 matrix, that is what we have right now, 40 by 30 actually. How many pixels we have? 40 by 30, 1,200. We should have, oh, magically, 1,200 red colors. One red color for each pixel. Yes? Okay. There is a component that does a similar approach. That is video averages. Is bitmap modified centroid of red pixels. What does that do? If we have a matrix, this is the best matrix ever. And for example, this one is red, this one is red, and this one is red. This is the center of the pixel, no? What is the centroid of this red? Here. So actually, red color is here. The centroid of red colors is here. Meanwhile, cannot go back with erasing. No. Whoa. So we have red, 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 and red. We have to triangulate all of them. Find the centroids. The first centroid is this one. Then I will simplify it, okay? But more or less this. And now the centroid between these guys is around here. So actually, this is the new center of the red. What this guy does is average the red colors. Let's connect it. Ooh, and we can see centroid of red pixels. Why we don't see it here? First, we have a mesh from image. Let's hide it. You remember how to hide? Center click on the mouse or space or right click and disable preview. Okay, now we see something here in the red bottom corner. Ooh, look, we have points moving. Okay, why? Because the centroid is a point. If we want actually to see the color, what we should do? Put a custom preview to show a color. So let's do custom preview. Geometry. We want to see this geometry. In which material is the color? Is swatch. Color swatch. Let's show it in red. Okay, so actually we have right now the red color. What happened? This is drawing not a rectangle as big as the other one. Why? In here we have changed the scale, no? This one we have changed the scale by changing the domain of this mesh from image. What happened? This component, just because it works like that, we have minimum point of the binding area that is 0, 0, and 1, 1. So actually what we have is a rectangle from 0 to 1, 1, 0. This is the image. It's just in a really small scale because this component just works like this. What we can do? Scale it up, no? Can we scale a point? No, but we can scale his working space by scaling the point. So if you just scale, for example, scale, what geometry you want to scale? What is the center of scaling? The origin. It will be changing the domain. If you scale by 1 by 100, you basically get from 0 to 100 on the working side. Let's scale this guy. So right now, the point is in the 0 to 100 of the same as the other guy. It's just in the bottom side. Do you understood this? It's a little bit of space location. The point can be moved from a workspace right now from 1, 1 to 0, 0, no? And the point is in 0. If we scale by 100, where is the position of 0? Still 0. If 1, we scale up by 100, what will be the position? 100, no? So actually, we are just making the scale bigger. If the center position of that is 0, 5, 0, 5, we scale by 100, what is the middle position? Still, everything is proportional. We are scaling everything proportionally. So what happened is, we can hide this, is the rectangle red right now, it could be in a scale that we can control. Let's do the same for every color.
Sorry, I cannot see the black rectangle up there on the.
This one. Ah, no, this is mine. I draw it.
Okay.
Okay. So actually, let's just to make it more visual, let's scale everything into a rectangle. So actually, let's draw a rectangle that is going to be our guideline. Rectangle of size 100 by 100. Let's make it square. Okay, this is our working size. So we just have a preview of our rectangle. I just draw a rectangle 100, 100. Let's do the same for all the rest of the colors. So we need to take the different geometries and scale them again 3 times. I can use the same slider to control all of them. And let's change the custom preview for each individual color. So actually, it's the blue pixels, and the green pixels. Okay, so we have the 3 colors. And we can hide everything here. Yes, so we have the 3 average colors on the image. And just in the moment I have the cap going in the image, it moves. Yes? Okay. So what we're gonna do now? Let's create some conditions. Let's do, for example, a random rectangle or a random polyline in Rhino. For example, this corner. If the red color gets in this corner, we want something to happen. Let's create a condition. Do you remember how we put reference lines into Grasshopper? We use components like geometry, that the rectangles, the basic ones that are in primary params, geometry. These are the extra rectangles, the hexagons, black hexagons are empty components. We can use to connect things inside the Grasshopper or reference ones. I will use we could use curve, yes. I usually use geometry that is a general all worker. It's not specifying anything. It's good and bad at the same time, yes, because you don't know visually what you have inside, but you are able to connect whatever. Geometry works with surfaces, three-dimensional shapes, clouds, points, data. Actually work with everything. Geometry is like generic component. Will be that everything. I work with everything. So ideally, you should use a component that's called curve. Whether we are connecting a curve. So we right-click and say set one curve. You just click, and now the curve is in Grasshopper. We're going to use a component that is what? Well, let's go to curves or surfaces, because we want to check that if point in breadth. And it's interesting, this part, because in curves, for example, curve, we can see if we have point in curve, point in breadth. In curve, we have different components. Point in curves, point in curve. In surface, we have analyze, point in breadth. If we connect, this is a breadth or it's not a breadth? B-rep. A three-dimensional surface, an object, basically. A NURBS object. A curve is a NURBS object. Actually, no. Or let's just try. We have the points. Let's take, for example, the blue points just because I have a blue cup. Okay, so we connect to the point and we connect the curve. Let's see what is the outcoming message. It says 0, and I hover over the component. It says outside 0, 1 coincident that is exactly on the line, and 2 is inside. Let's see. Okay, 2. There's a moment that is really fast, the moment that it should be 1, but we don't see it because the line has almost no space. So
how do you link the curve to the curve?
Right click, select the component, right click, set one curve.
Set one curve.
Set one curve, and you can select your curve, and it will automatically update. So right now, let's do the same with point in breadth. Let's connect the geometry, the breadth, and the point. And it's in red. Why? Sorry. Yeah, it's opposite. So I connected the things actually the opposite. So let's point, and the breadth is the curve. It's in red. It's not in red, but will show me something false. Actually, it's not changing. Why? A breadth, also as you can see in the drawing, is a three-dimensional geometry. Could be as simple as we make this a surface and we extrude it. For example, we can make it a boundary surface, that is a component that takes the edges, creates a surface, and we can extrude the surface. In that case, it'll work. Extrude. What is the direction of extrusion? For example, the Z, no? So right now the component works. Why? Because the point is inside this three-dimensional, even if it's really thin, it's a three-dimensional space. So actually, for example, you can work with this not only in plane in 2D, but you can even work in 3D at some point. If you, for example, project the point in the surface of the mesh. This is just to show you the difference between a point and a curve, a breadth and a curve. We don't need it. So right now we have a problem, that is we got zeros and twos. What we can do? We can make a little condition. We can either do two things. Remap from 0 to 2 to 0 to 1. In case we get the 1, will be 0.5. Could be a little bit random, that element. Or we can make an equality. If we get a 2, give me a true or a false. So right now we are getting true or false. It's 0 and 1. But just making a simple condition. Is equal to 2 or is not equal to 2? Yes? Okay. So right now we have already the condition. Let's send a message that is not a true or false. Or actually we can do this to light an LED. Let's do it. In order to send this value, this is a value that we can send it to the serial. What we need to do in Firefly. So far, what we just did is just Grasshopper, but with the camera of Firefly. We have this component. Let's go to Firefly again. In order to send anything to the serial, to any board, we first need to see where is the Arduino connected, no? The COM port. Arduino and ports, COM port available. And we always will take up also open, close port. These two guys. This will put a panel in the COM port. And for example, I have an Arduino connected to COM number 13. This COM, this is actually the element, the little script that will connect to the port. And we need to state what is the speed of communication. Though we don't need to state it because by defect, it's at, if we hover over the element, it says by define locally by 115, 200. So has already a determined speed. What we need to do is open or close the port. Boolean. We just connected. And let's see the message. Okay, Arduino. Adrian is actually opening his board, so let's wait.
Because I don't see anything in the panel of the open board. It should
Here.
automatically.
Here, COM port available.
Yeah, there's nothing connected to the panel.
Okay.
But maybe was working with the USB extension.
And there is a component that is called time. Let me 1 second. That. Mhm. Yes, until 1:32. Mhm. Okay, Adrian, if it doesn't show, just try this component. Trigger, and right click to interval 10 milliseconds. What this component is doing, what do you think it's doing? For example, this kind of component needs to check if something has been connected. Does it need to check all the time, or we just can check every minute, for example? So basically, with trigger, what we are saying is like recalculate only this component at this time. So some components, they don't update properly because okay, how Grasshopper works is everything is recalculated every time you put a new component, all the script. That's why sometimes when you put a script and you have a really long script, it takes a lot of time to actually unfreezes. Why? Because it's recalculating everything. We can see, for example, on the bottom part, autosave complete 110 seconds ago. In general, saves every 2 or 3 components. So in the moment, for example, I put another component and I connect them, this will not work. In theory, in this moment, it just recalculates everything. If, for example, we are just waiting for this panel to update without connecting anything, it will not show up unless we put another component. Okay. So we have this one that what it does is, it doesn't matter what, it will recalculate those specific components at that time. So actually in Firefly, as we want to have continuous updates on the serial, we want to connect to a timer, for example, every 10 milliseconds. If it doesn't work, just take another. Okay, so we have opened the serial and it says, hooray, the serial port is open. Actually, what we just did it is tell Grasshopper, okay, you are going to use the serial. And this is going to be the serial you're going to use, nothing else. So what we need to do now is Arduino Uno, write or read. We want to send things to the Arduino, so it will be, for example, Arduino write, Arduino read. Okay, and you see that there are several ones. Uno read, Uno write, mega write, do a read, do a write. And then we have serial generic, write generic. When you use Uno, mega, or due, is because Firefly is an environment made up to simplify things a lot. What happened? A lot of people doesn't know how to code, but they know how to do visual scripting like Grasshopper. So actually, when you install Firefly, a new menu shows up. That is Sketchbook. Firefly firm data. And it's open somewhere here. That's why it's not open. Yeah, here. And all this shows up. So it's a made up code to work transparently with Grasshopper. So actually, we don't need to, we do it in a simpler way. For example, Arduino Uno bright. And we can address each pin in a menu. Okay. But in our case, we are making the lines of code on Arduino because I wanted to understand what is happening, not to be the black box. So you're able to modify. And also, most of you, you will not use Arduino Uno, you will use ESPs. So actually, this work doesn't work for you. So
Even with the generic?
what we do is generic.
Ah, okay.
With serial write generic, what we do is actually, this is the data to write. That's why we need to make our own messaging, like the 001, 01, or AB, AB. Right now, we can send any kind of message. In the other one, you can only send ones or zeros or ones to each individual thing. Basically, this, what it's doing is mixing all the data in the message as we are saying, as we was explaining before. Here, for example, we can have 0 and 1, 0 and 1. What this is doing is actually merging everything into one message. In our case, we need to do it here ourselves. And the good point is we can encode it as we want.
Do we need Arduino or Grasshopper using the whole PDS?
For what?
Like in the Arduino IDE, I don't need it.
No,
It's going to be okay.
no. If you use the blocks of Arduino Uno, you don't need coding. In this case, when you write serial generics, you need Arduino because you need to code it. So what are the things we need is asking? Start breaking values is a Boolean. We want to send data. So let's put the Boolean toggle on. Okay. What is the data to write? Or which port? Again, is the same port. Yes. And what is the data to write? Right now, we're gonna send only zeros and ones, trues or false, no? We have it here, true, false, true, false. So we can just send on, off. Okay, let's put a panel to see if it's actually sending the message. Right now it says null. Why? Nothing is being sent. This component is off. We need to, yeah, no, the port is open, but we are not sending yet anything. So let's say, okay, write data to Arduino, and it's actually showing what we are doing, what we are sending. So right now, all the Grasshopper part is done. We are actually sending things to the Arduino. Why the Arduino is not doing anything? Because it doesn't understand the message. As simple as this. Right now, the Arduino code that is inside is this one, the one that I was showing you before. That is, if data is A, if data is B. We are sending zeros and one. So actually, it makes no sense for it. Let's make a new code, okay? A simpler one. Okay. Let's write an LED. I have an LED connected to pin number 12, plain LED. Let's just blink the LED. So what is the first thing we need to do? We want to talk with the serial. Is actually serial begin. We want to also check if the serial is available. Actually, this is already. If the serial is available, let's do it clean, the code. If the serial is available, what are we going to do? Read the serial. Actually, as we have, when we want to transform it, we can read the serial. This is the component that is going to read the serial. We can transform it into a variable, integer, or not. Actually, what we can do is, what is the code to write an LED? Examples, blink. I always show that coding is quite basic. What is the right to code and write an LED? Digital write. Where? pin number 12 in this case, and the value is high. It means read. What we can do now? Also, we need to initialize the output. Sorry, I forgot that the pin mode is the 12 is output, and we can this component we can actually put in here. Why? Because the value that we're sending is 0 and 1 is automatically. Why? The value that we are sending is this. So let's check if we can actually send this guy. And it will say no. Why? Here I have the COM open. I need to close it in order to program it. The port is already being used by Grasshopper. So I need to close the COM. Select the COM in here. Check that you have an Arduino. Okay.
What you will read is the terminal. What is that?
Some that could be. That's what we're gonna check now. Okay, the code is on. Let's switch on this guy. Actually, why? Right now the LED is on. Oh, what is? And you will say why? If serial is available, serial read this guy. What is happening? It's not changing. The LED is, I don't know if you see in the camera, but the LED is on all the time. Because actually, what you are getting is not a high or low, it's a string. It's a communication message. So we need to transform that. It's not the same an integer, that a char, that a string. There are different types of communication. So if you open up the serial, it doesn't work because it's open. That's the bad point. We need to transform this serial read into another kind of information. Let's link, Firefly, link, sweep. So here, even if the data we are sending is a 0 or 1, it's not a boolean. It's a char. That's why we need to transform it and make an equivalence of characters, because the type of encoding is different. So that's why in here we are doing this and not just setting up 0 and 1. Even if the message is 0 and 1, it's a char. It's not a boolean. It's not an integer. It's a little bit tricky. So we need to make conversion between integers, characters, numbers, etc. for whatever message you send. So let's put this guy. That's why we cannot make the equivalent just straightforward out of the box. So let's just make equivalence between them. Actually, just copy this. If the data is 1, if the data is 0, we will light up 0 high or 0 low. You understand this? Yeah. So let's try to load it. Again, to load it, we need to close again the serial of Grasshopper and send it. Sorry, the code is wrong. I just changed this name, so I need to change it here. Yep. Okay, so now let's open up. It's not working again. We got numbers are not the same as characters. That's why. So in order to send this properly, for example, we can do actually like B and D, for example. or like X. What we need to do is send these guys with a, right now with this, we are having a true or false. How we transform a true into a character and a false into another character. We can do the same as this. Is if false equals 0, we get an activation, we can return a message. But there's something that is easier, that is called a stream filter. There is a stream filter and a stream gate. So these components, what they admit is a gate. What is the gate? Gate 1, gate 0, gate 1. In this case, it's the same. Gate 0, gate 1. A gate is defined by what is a stream. For example, a stream is letter, I don't know, B, and letter X. Let's put a panel to see the output. Right now it's letter B. It's going only gate 0. How we change the gate? By a true and a false. So you see, we just change. It's like choosing one stream or the other one. So like this, we can change actually the type of messages to be sent. It's really widely used. If this is a way, is if this, else the other one. It's a condition. So instead of connecting the booleans, we connect the gate. This is the data to write. X and B, X and B, X and B. I don't know if we have updated the code already. Sketch, what is Blink? Blink? No. Sorry. Script, Arduino, Sketch, this guy. We didn't update it, so we need to, I need to reload the code in the Arduino. Let's close the port. Let's just put capital. The long one. B and M, for example, be uploaded. And here will be B and M. Done uploading. So actually we can use the serial. Okay. Do you see the LED blinking? Yes. I don't see the camera. So. The LED is blinking. Depending if the blue cup is in the square or not. So as long as we get these messages, we can connect a LED or a servo associated with different positions. Another option, this is position, colors, etc. So can we do the opposite? Read something, for example, a sensor, and get it up in Firefly? Yes. For example, this is actually we are is 1:15. What do you prefer, to keep going with inputs or going to the robots? Like the robots is already recorded completely, the class from 0 to scratch, but I was only going to repeat. What do you prefer, to go on inputting? Okay. So actually, this guy is a joystick. These joysticks, what are they? It's potentiometers. Two potentiometers, one for the X and one for the Y. And they have a switch button also in the middle. So let's connect this guy into the Arduino. So I will disconnect the servos and also connect the buttons. Ground with ground. 5 volts. Okay. Analog, this is analog, so analog 0 to X and Y to analog 1. Okay. So let's make a new code for, in this case, let's make a new code. How we read an analog sensor. Examples, basic, analog, read serial. Because when you read a sensor, you want to see if you are reading it. So actually you're automatically doing this. So let's change the speed of communication. So we'll match the Firefly one. Okay. Let's take out the little piece of quotations that we don't need. We are reading analog 0 and we serial print the value. Let's read just one of the joysticks. Okay. Click, upload. Maybe we are not, I don't know if I have the port open or closed. Problem of loading. Why? Can open the port. Why can't open the port? It's opening Grasshopper. Okay. So let's try again. Uploading. Perfect. This is the values of one of the joysticks. Good, no? Okay. We don't need to do anything else here. Let's go directly to Grasshopper. Let's start fresh. Let's say we have a new one. What we need to do? The com, in this case, is open close port again, the same. And read, serial read generic is the com, and a boolean. Let's put the panels to see if it's opening correctly or not. Right now it's closed. Let's see the message. Right now everything is off, no? So let's see. Why? Font 13 is denied. Interesting. Might happen that this is making collisions. Oh, yes, that's true. The serial monitor. Yeah, we need to close the serial monitor. So let's open it, and you see that we can see some values, but it's not updating. Why? The time trigger is called interval 10 milliseconds. Update please. Update please. You see the difference? Now we have actually 3 values. Why we see 3 values and sometimes we see more? The difference between the loops of the speed of one to each other. We're actually reading more than the other ones who actually repeating the last data. It's something that is quite easy to clean as just take the first item of the list, because the first item is the most updated one. Okay. We can make the bot rate slower, but actually what you want is always to be as fast as possible to be more reactive. So we just put list item. So we just get the first one. List item, and it's not getting the first one of the list. How we did last time. Because the speed is changing so fast that we only need to utility. Let's buffer the data first and then just take it to value, buffer the data. Or what we can do is as say that could be how I did last time, I don't remember. Let's look. Let's see how we can clean this. Before we keep working on this, let's put the other sensor. So we finish the Arduino side. Analog radial C here. So let's read the other sensor. Sensor value 2, analog 1. And we want to also serial print the other one. No, in analog no. Sensor value 2. And we want to, we're gonna send the line of the first sensor, and we're gonna put a comma between, because this is the way I'm gonna code my information, my sequence. Let's print it. Let's see. Is it reading properly? One direction and the other one. Perfect. I can have both. We can even have a third one that is the button on and off. So if we add a third one, will be analog 3. If it's a button, but analog button, I can read it also with an analog port. Just it will be not be exactly on the top, or the lower one will be an not that good value, but it will be also okay. Sensor value 2, sensor value 3, sensor value 3. And you see that I have print, and then println. We need to send everything in the same line. Let's close the serial. Reading. Okay. It's not reading. Switch. Let's go for read in a digital one. Maybe the switch is broken. I don't know. Digital read and 7. Interesting. You see, sometimes it's 0, 1, 0, 1. This switch is not pull it to low or pull to ground in the board. So actually, we need a resistor to pull it low or pull it high. So it's a really bad switch actually for being a breakout board. Okay, well, it really doesn't matter. This is data we're getting. Doesn't matter what data is.
Wait, does it stay there by reading and you move to the other side as well? Okay.
This is X. This is Y. And the third one is supposed to be the switch that is not working properly. It's broken.
And you do like X and Y together?
Yes. No, actually, it's, for example, I'm touching with my fingers. I'm pulling too low. So actually, in the back of the PCB. So touch sensor. Okay. So let's go. Let's close the serial. In theory, we're getting the data correctly. And let's see what data we're getting. Let's open. And actually, we can see what we can do is right now is split data with commas, text split with a comma. And we can see the first line that is sensor 1, sensor 2, and the third one that is actually the switch that is not working, the line 3. That it will be this guy. So let's list our items.
What's the length for the comma?
This
Yeah.
is just a panel, and I just type a comma inside.
Okay.
For example, could be a comma, could be a slash, could be whatever you want.
Okay.
So right now I have my second data. With list item, we can say, take me the next one too. That is the second slider. And let's see if we can still get the third one that even if it's broken, it's really bad. Actually, no, because why? We have a jump line, but we don't have a comma after it. So actually, this is something that we can solve just by adding a third comma. Okay, so we have two numbers. What we can do with this, for example, construct a domain, construct a point. So we have a point. What will be the range of the point? So this point right now is too huge, let's say, or mesh or workspace is what? 0 by 100. So what we can do is remap this number. Do we know the source number?
0 to 1,024.
Exactly. Is the analog values. So we put a constraint, actually construct a domain. We need to construct a domain from 0 to 1023. It's going to be the source one. And what is the target? The same as we have this rectangle that is 0 to 100. If you don't remember, is somewhere around here.
Is that the one?
This one, yes, remap. So we want to remap this value into this value. And we will do the same for the other one, for the second. Actually, now the mapped one should be domain. Sorry, do we did correctly? Domain. I didn't change the. This is why you need to make space between the components. So you don't mess up anything. Okay, the source is from 0, domain start 0 to domain end, source. And the target is from 0 to 100 for both. So now the target point is here. You can see I'm moving the red dot. What we can do? For example, we can make a sphere in the point. For example, of 20, a super big one. So now I can play a game. If the sphere touches the blue dot, that actually is my camera tracking, I can activate a servo by testing a point in a graph. So for example, I have this, let's make this sphere smaller. Let's type this guy. And we have this blue dot. So I can play a game between the cap and my other coordination on my hand to actually try to catch the blue one. And if we both with collision, we can send a message back for activating a servo. So we have the point that is the blue one that is still here. In this case, we use the pointing curve. You remember that we use the pointing rep. Instead of using the surface of this guy, we can just move it to this one, okay, and test if the rep is inside. Let's show it. Right. It's true. Yep. Actually, you want to try to catch my cup? Yes. And this is actually, this is just, for example, what we can do is, if how to visualize this more than a true one or false. We can even draw, change the color of the sphere. Exactly. Color, custom preview. We're gonna make different colors. Color swatch. What is color swatch? For example, let's make a super fancy color. Green. fancy. And yellow. Actually, blue is not good for this. What is geometry to preview? The sphere. How we can choose between two colors with an integer? Exactly. Stream filter. The gate activates stream 1 or stream 2. Okay, try to take the blue color. You see how it changed the color? Automatically? Let's make the sphere bigger so it's easier. But now, let's move the camera here so you can actually see how I'm moving the camera.
How can you down to the because like you did a stuff and I dial on the stuff.
This guy,
Yeah.
erase the component and place it again. Or you have this play button so they can stop it.
Right.
Okay, and that's, for example, how you can make this is a little video game interface. And right now this is ugly, but because the point, this is a point, but this could be, for example, instead of a point, could be, I don't know, a polyhedron. I don't know, you have the component polyhedron. I think I have dodecahedron. Dodecahedron, platonic dodecahedron. This is the plane. The radius, let's make it smaller. And the color is actually the dodecahedron. Why we don't see? Because it's an invalid red. And dodecahedron. Well, let's put another sphere. We can put a fancy preview, Arctic. Actually, this one is ray traced or rendered. Okay. And Josep, mira, cámara tracking y él me intenta coger con la pelota. Es un juego.
Can you take the time to actually
Actually, yeah, we have something that is, this is the condition, no? Firefly, some component has some really component utilities that are, for example, bank detection. Detect when something has changed states. And we can have it to activate another gate, this, and we can, for example, data log. We can, this is incoming data. And what we can do is make, for example, a mass addition, because we are getting trues or false, trues and false. With mass addition, we can get, this is the input, why is not working? Addition defined between booleans and booleans. So actually we need to make the translation between these two zeros and one, and then we make the mass addition. Sometimes, like actually this boolean sometimes works just to use the component as number. Yeah, 0 and 1. It does it for us. 67 times. 71. But think that we are getting more activations because actually every time the sphere is inside, it's count 1. But it's doing it several times per second. So actually we'll need to put a timer to only update the component, for example, every second. So actually we only save every second. That will be depend like counting sensibility. Because you haven't catch me 100 times, okay? I'm not that bad. And
I have a question.
we could even do something like even further, that is here. Let's put it in normal one. You have the mesh, no? That is the image. We could make this three-dimensional by having a third value of another sensor. For example, light makes the ball in the sphere in Z, and the blue one is projected to move three-dimensionally based also on the camera input. This is just we're working in 2D planes, but the Z is we are working with points. So actually, the point also can move in the space. So this point, this is the mesh, and this is the point that we are with tracking. It's on the bottom. We could project it to the surface just at the beginning, and we will have the point three-dimensionally in the space. But this is like we can always complicate more and more and more and more. So yeah. Question?
Did you like redo this, rework this sensitivity for this certain language?
Yes.
Like say for instance, you wanted for the lower ranges to be like
This about actually a lot of times I just read the pure data in Arduino, and we can do remaps. Actually, the remapping thing we do here, we also have the component in Arduino. We have also the smoothing. For example, PID. We talk a lot about PID. PID control. And instead of trying the numbers in Arduino, you just try them here. Frame rates, constraint, buffer, fader one way. This is basically a time stop, like changing to give you a serial data changing from 0 to 1000 and 1000 to 0 to give, for example, a servo swap all the time. And then conditions, NOR conditions, like double addition conditions, state detection. Also, we can check if a key is pressed, for example, to have more interactivity than just the plain video. If the geometry is selected, you can also say if you have selected something Rhino. For example, we can associate the frequency spectrum and change the Z that depends on the audio level. So if you shout because you're happy because you catch me, the both get separated in the space. Yep. You have any questions?
The visualization is always like right now, like it's only in line, but is there a way to exploit that, like as an outlet or something?
No, no. The closest way to get out of Rhino let's say the visualization interface is using another plugin of Grasshopper that is called Human UI that allows you to create interfaces, but you need Rhino running on the back. So you can have it minimized and have your own interface, like a proper interface, but you have to have like the same as you can listen to music in Spotify, but not have a Spotify showing, but it's the same. Human UI is quite easy to work with. Like it's a nice, clean way to make interfaces. Another option is if you don't want to see Grasshopper, but you still, for example, want to play with some sliders. What you can do is, for example, this is the size of the sphere, no? Let's say I want to be able to change this just from Rhino, not from Grasshopper. You can right click and say publish to remote panel. By publishing to remote panel, what this guy does is in Rhino here, one of these tabs gets transformed into remote panels. I don't remember which one. Blue. I think we need to show it here. You see Grasshopper somewhere around? Yeah, Grasshopper. So we have the slider here. Actually, we can change the value just in the Rhino interface, not in the Grasshopper. Not a huge change, but well, something is something. It's better than anything. Yeah, but actually when both spheres touch it, it's not the same as a point in the sphere. It's actually just the center of my sphere. For example, don't move. This is not the same as this. That is actually in the center of the sphere.
The flashing part is gonna do is Rhino.
No.
When I put the to separate the comma, I took only one input, but it's not working so. And I didn't have the I plus one, What happens when you get the input for it?
You are talking about Rhino or Grasshopper? Because Grasshopper or
Grasshopper. The second part, when you're reading the serial with the three values of the testing,
yes.
here in the list item, you have I plus one, I plus
This is how to take this one. If some components, when you zoom in, a plus and a minus appear.
okay.
So,
Okay.
actually, you can. Right now, we are taking index 0 plus 1 is index 1, index 2. It's a way to don't have to put like a lot of list items with different numbers. So you can actually like take different index from the same list. If the same as if you go on the negative, you take -1. That is the last one of the list. Quite useful. For example, in stream gate, I don't think it works, but some of them, what is some components? Yeah, for example, stream gate 2. In that case, the gate, you will need to have a gate that is 0, 1, 2.
Question. For the first part, when you detected it from the bread or no, in the panel it was showing true or false.
Where?
The last part of the color detection inside the bread.
Color.
When you detected it, the point was inside the bread.
Yes. Yeah. Here we have the serial.
Yeah, the first example is like on the top. Here.
Yes.
Here it goes in the panel, it says true or false, but it sends 0 and 1 to the zero, or what is the
This says true or false. A true or false, like it's a little bit of Grasshopper. Like false is 0, true is 1.
Okay.
But in some cases, equality sends zeros and 1. But before it says a boolean cannot be a number. Depends on the Grasshopper component. Equalities are like for numbers in theory, they automatically send zeros or 1. In most of the cases, if it's not sending a boolean, what you do is use, for example, this one is stating, this one is Boolean, no? Output log. If I, but if you, I hover over it, you say it says A text. It says A, that is text output log. If I connect to number, I transform the Boolean, that is a Boolean, a plain Boolean, into a number, and by so it's still the same, but different ways. It's like the same as integer and characters.
Yeah.
Okay, if there is no more doubts, oop. Okay, hope you like this. There are really nice examples in the page that is Firefly experiments, when they play a lot of with audio, visuals, like a camera with tracking drawing to actually draw, for example, sounds, just by how you draw on the paper. With the contrast, this contrast detection, you see the lines, black lines with a blue on a white paper, and you can actually paint notes. Because what you get with a camera, what is a XY pattern? XY, frequency, spectrum, intensity. You can level, for example, with a potentiometer, an Arduino reading, and actually play music just by drawing.
Can you do something like mapping the room?
Mapping?
Mapping the room. Like if you have a LiDAR sensor. You need to put the data to remap the room.
To 3D scan.
Just do that to 3D scan.
Yes, actually that's how you do it. Like you can do it with like that.
Okay.
A little bit. There, the problem is about how you actually locate the data properly.
Okay.
But yeah.
So yeah, you could like recreate every surface inside environment.
There are examples that is widely known that is like they use a ultrasonic sensor as a 2D sonar.
Okay.
Actually, there are some example, lot of examples with that with processing. Let's just look for it. It's doing the same. It's reading the data with serial, and instead of using Grasshopper, they use processing to code it.
Okay.
But
What's it called?
Arduino Sonar processing. Yeah. Let's see the video. So basically, you have a servo swiping up a sonar, and this is getting actually the distance.
Oh, I see what you meant. Now it's all about how you extract the data and take from it.
Exactly.
You want to recreate a room.
Exactly. The sonar is the less accurate sensor ever, but it's conceptually is the same. The difference is like in the moment you have 3D, everything gets messy, and also depends a lot on the distance. Think that 1 degree at 1 centimeter doesn't make a difference. 1 degree at 50 meters makes a huge gap on the distance on the prediction. So, and this uses exactly the same. It serial prints the distance, and basically you are reading that, and we have the virtual representation. Processing. Processing. You will work on it on processing. Processing. Imagine the Arduino, but for creating interfaces. It's a plain program for visualizing things. Actually, it looks exactly as Arduino, but in black. So processing Arduino are usually two programs that they compare to in the moment of interfaces. Yep. Okay. Done for today. Bye bye. Remote.
Thank you.